Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so this is an alternating series. When it comes to an alternating series, you discard the alternating sign. So you discard this. So you discard this, and then extract your un. So extract your un. So this is your un. Make sure that all the uns are positive. So uh, n is moving from 1 to infinity. So just looking at the un. So discard this. N is moving from 1 to infinity. So this will always be positive. This will always be positive. This will always be positive. The whole thing will always be positive. So un will always be positive. So now check number 3. So make sure that the limit of un tends to 0 as n tends to infinity. So let's check condition 3. So condition 3, make sure that the limit of this equals 0. So as n tends to infinity, if you look at the numerator, the highest power will be n squared. Look at the denominator, the highest power will be n to the power 3. So now you can see that as n tends to infinity, the whole thing here will tend to 0. So the limit of this whole thing here equals 0 as n tends to infinity. So condition 3 has been satisfied. So earlier this has been satisfied, this has been satisfied. If all 3 conditions have been satisfied, then we can conclude that the series will converge. So now we need to check condition 2. So condition 2 says that it says that un must always be non-increasing, meaning it has to be going downhill all the time. Because of this equal thing, it can stay the same. It can stay the same, but make sure it's always going downhill or stays the same. So now we need to check condition 3. Make sure that it's always going downhill. So turn into a function. So turn our sequence into a function. Now to make sure that it's always going downhill, differentiate it and make sure that the derivative is always negative. So this is our function. Now differentiate it. So hang on. So let's this is our function. Let's just multiply it. Multiply the numerator out. That will then give us this, and then now differentiate it. So use the quotient rule to differentiate this. The quotient rule is it will be this thing squared. So remember the quotient rule: v squared, v stays the same, u prime minus blah blah blah. Differentiate this. That will then give you this, and then if you look at this, if you look at this, and if you look at this, n plus 1, n plus 1. So you can factor out n plus 1 squared. So now this will cancel out with this down here. So that will then take you to here. Because multiply this out, that will then give you this. Multiply this out, that will then give you this. So now it's just a matter of tidying this up. That will then, so now n squared, 2n squared minus 3n squared, that will be 1n squared. This, take away this, that will be this. And then single number, that will then give you this. So now you can actually tell, well, factor out the negative 1 here. So now you can actually tell for sure that this will always, you can tell for sure that the derivative will always be negative, because remember n is moving from 1 all the way to infinity. So this will always be positive. This will always be positive. This will always be positive. The whole thing here, this whole bubble here, will always be positive because n is moving from 1 to infinity. So well, if this whole thing here is always positive, you've got a negative here, making the whole thing here always negative. So if the derivative is always negative, it means it's always going downhill. So going back to this condition, going back to the initial problem, this has been satisfied. It hasn't been satisfied. Now we can be sure that that is always going downhill. So condition 2 has been satisfied. So therefore we can conclude that the whole series will converge. Okay, this alternating series will converge.